Hello, this is for the section 3 fire hose. As you can see, we have created this fire hose stream vehicle data F8 stream. So it's a Amazon data fire hose, and we will push data from our Raspberry Pi with Boto 3 in this fire hose. So let me show you the program. So we have used this Boto 3 package, and I have mentioned access key for that, and I have used the name as vehicle data fire hose stream, and I will just demonstrate pushing the data here. So as you can see, it's successfully sending data over to Firehose, and if we want to see the data, it will be loaded in the destination S3 bucket. So this is the latest version, and we can see that the data is getting loaded here. Thank you.
Hi, welcome to lab CS437, lab 4, part 3. And the objective of this particular lab was to ensure that we have the ability to bring in the data from different vendors and different, I would say, sensors, and visualize them, store it in a database, and then primarily build visualizations on top of it using Jupyter notebooks, which are deployed on SageMakers, right? So we talked about, and this is where Shaumya left off, where we are talking essentially about the data vehicle streams being written, and this was the Firehose stream that we created to write the data into an S3 bucket. Once the data is partitioned, we were able to create the crawlers and the glue jobs, and we can look into it using Athena. As you can see, we have written a query, and as we run it, we are able to see all the data underneath it. It has a vehicle time, some of the emission factors, vehicle fuel, and so on. And also there is the vehicle ID, vehicle lane, position, routes, and so on. For each one of these elements, the next step for us was to set up a SageMaker, I would say a SageMaker service and SageMaker notebook, and we have created this notebook. As part of this notebook, we wanted to install some dependencies. We were able to install PyAthena. PyAthena is used to connect to the S3. We also imported pandas, and we connected to the database. We ran into some issues regarding this, and using the instructions provided, we were able to provide the right IAM roles to build this. So this is where we are actually getting the data and loading that into a data frame. We did I would say 3 visualizations as part of it. You can see the data frame being here. We downloaded the PyPlot as well. The first visualization is just a very simple CO2 emission by vehicle, just ensuring that we have the ability to showcase what's the emission by timestamp of different vehicles. That's what you can see here. There's a similar CO emission that we have as well, where we are essentially extracting CO emissions, and there's a timestamp ID as well here. Coming down, what we wanted to understand was that is there any correlation between different, I would say, factors and different variables that we're currently evaluating. And for this, we used Seaborn. This is where we're kind of creating a correlation matrix, and we're using a heat map to find some of these correlations, right? And as you look at this particular heat map, you can see there is a lot of correlation between all the emission factors that you see here, which is CO, CO2, particulate matter, NOx. So overall, a lot of correlation here. And there is actually, some correlation that you can see here as well. Some of the other factors such as position, speed, they are not really correlated. So just from a statistical perspective, just doing some exploratory data analysis here. So this is the end of the video. Thank you.